Consider an equilibrium reaction represented by A plus B giving C plus D. This shows that the system is at equilibrium. That of arrow is enough to show that the system we are talking about here is at equilibrium. I want you to know the difference between the arrow that we've just written or drawn and this other arrow. This generally talk about what is reversible, the reaction that is reversible. But when it is half arrow, half double arrow, then that is a system that is at equilibrium. Now, based on this our consideration, if the concentration of B is increased, concentration of B is increased, the principle says that the equilibrium will move in a direction to decrease, or rather to reduce the concentration of B. The system will move in a direction that reduce or decrease the concentration of B. Therefore, move to the right. So that this means the equilibrium must shift to the right hand side to produce more of products. We want the B that has been increased. The concentration of B that has been increased should enable more used up of that B. The B should be used properly so that that concentration of B is reduced. And that is why the equilibrium shifts to the right, or the system shifts to the right hand side, meaning the forward reaction is favored. It can be concluded that if the concentration of one of the reactants is increased, very important, if the concentration of one of the reactants is increased, then the equilibrium will shift to the right hand side. Shift to the right. Leading to higher proportion of the products. But when concentration of one of the products is increased, then the equilibrium will shift to the left. Equilibrium will shift to the left and side, leading to more of the reactants. More of the reactants. That is, the left hand side will oppose that change in the equilibrium. More of the product, for instance, if it is D, increased, will shift in a way that the increased D may be used up to form more of A and B, leading to more of the reactants. Examples. Number 1, a mixture of bromine liquid and water, when shaken and allowed to stand, the following equilibrium is obtained. That is, bromine gas plus water and that gives the bromine water HBr. Is there the bromine water? So that will give us ionic equation. Bromine gas plus water gives, this will ionize to give us hydrogen ions plus bromide ion, then that will also give Br ion. So this is colorless, then this is yellow orange. Yellow, or we can talk about the orange color. It is orange due to formation of the bromine water. Now, we want to see the effect of adding some other substances to this equilibrium. Let us look at this. Addition of sodium hydroxide solution. Sodium hydroxide solution has hydroxyl ion, which will react with hydrogen ion in the equilibrium to form water. So this hydroxyl ion from the sodium hydroxide will react with hydrogen ion that is in the system, and that will lead to formation of water. It means that addition of sodium hydroxide brings the hydroxyl ion that removes hydrogen ion from the equilibrium mixture. and that will make the equilibrium shift to the right in order to replace more of the hydrogen ions being removed. This makes equilibrium shift to the right for the hydrogen ions removed to be replaced. Remember, the system will shift in a way to oppose the change. You know, the hydrogen ions has been removed from the system by bringing in sodium hydroxide, which has neutralized, has brought in the hydrogen hydroxyl ions that reacted with the hydrogen ions to remove the hydrogen ions. So the system must shift in a way to oppose. It has been removed, so we have to bring in. That's why the system must shift to the right for more of the hydrogen ions that has been removed to be formed. Therefore, color changes from yellow to colorless. Observation will be color changes from yellow orange or yellow orange to colorless. Because the colorless is in the side of product and the system will shift to the right. So the observation is that orange color or yellow color changes to colorless. On the other hand, when we add hydrochloric acid, addition of hydrochloric acid, that will bring hydrogen ions, which reacts with the colorless bromide and hypobromite ions to form yellow orange aqueous bromine. This will make equilibrium shift to the left. Shifts equilibrium to the left. You know, there is hydrogen ions in the right hand side. I want you to check that keenly. So when we add the HCl, the hydrochloric acid bring more of the hydrogen ion. In fact, we have 2 moles of hydrogen ions there. So hydrochloric acid will bring in more of this. That means there will be more reaction between the hydrogen ions, bromide ion, and that hypobromide. And that is why there will be more formation of the yellow-orange color. And we have said the equilibrium will shift in a way to oppose that change, and that is why the equilibrium shift to the left to oppose the addition of that hydrogen ions. Let's look at second scenario. Acidified chromate ions exist in equilibrium. So that is chromate ion, that is yellow. Plus 2 hydrogen ion, and that is the system at equilibrium, giving dichromate ion, that is orange. Plus water. Let's see the effect of acid and base in this reaction. The first one is addition of acid. For example, we can talk about hydrochloric acid. When acid is added to this system, the equilibrium will shift to the right. Shift to the right. So that more of the hydrogen ions added may be used to form the more of the dichromate ion and water, and therefore color changes from yellow to orange. That is the observation. You don't talk about equilibrium shift to the right under observation. You say the yellow chromate ion turns to orange dichromate ion. Why? This is because the hydrogen ions added will bring more hydrogen to react with the chromate ion to form more of the dichromate ion. And that is why the equilibrium shift to the right is favoring what we call the forward reaction. Next is addition of a base. And that is, for example, sodium hydroxide base. The base will bring in what we call hydroxyl ion, and the hydroxyl ion will try to neutralize the hydrogen ions in the system to form water. So the equilibrium must shift in a direction that opposes that effect, and therefore equilibrium shifts to the left. Remember, the hydroxyl ion brought in by the sodium hydroxide will reduce the concentration of hydrogen ions. So the equilibrium must just shift in a direction that would form more of these hydrogen ions that has been removed by the hydroxyl ion, that is from sodium hydroxide. And that's why the observation is that the color changes from orange to yellow, or you can say orange dichromate ion turns to yellow chromate ion. And we have said that is because the backward reaction is favored in order to oppose the effect of removal of hydrogen ion in the system by use of sodium hydroxide. So that is all about the effect of concentration in the equilibrium.